All right, so we're almost through all of chapter 6. And today we're taking what we had learned about systems of equations and applying it to systems of linear inequalities. So we're merging together the end of chapter 5 with all that we've been working through in chapter 6. Primarily, actually, the first section of chapter 6 where we were graphing. So first, I just want you to think about this problem. How do you think you could solve it? Take a guess, think about it for a couple seconds, and then we'll move on. And we'll come back and talk about it at the end of the notes. But how do you think you can solve a problem that looks like this? In a marching band competition, scoring is based on the musical evaluation and the visual evaluation. The musical evaluation score cannot, exceed 60 points. The visual evaluation score cannot exceed 40 points. What are the possible scores that they can receive? So, I want you to be thinking how we can possibly apply these properties that we've learned in systems of equations to solve this problem. So think about for a little bit, press pause, but I'm going to move on to start defining some things. So a system of linear inequalities is also called, a system of inequalities, and it's two or more linear inequalities in the same variables. So an example would be x minus y is greater than 7 and 2x minus 8 or plus y is less than 8. A solution to the system is just like it is for a normal system. It's any ordered pair that is a solution to both inequalities. So there's going to be multiple ordered pairs that will be a solution to both, and any one of them is just considered a solution. So an example would be that a solution of this this system here would be 6, negative 5. Because if I put a 6 in for x and a negative 5 in for y, I would get 6 minus negative 5, or 6 plus 5, which is 11. 11 is greater than 7. And if I put a 6 and negative 5 into this one, I would get 12 minus 5, which is 7. 7 is less than 8. So 6, negative 5 is a solution to both. So now let's talk about how we can determine some of those solutions. And to do so, we're going to need to graph, okay? So in solving a system of linear inequalities, our steps look like this. Graph the system and then find the intersections of the shaded region. So let's look at an example to hopefully help it make sense to you guys a little bit better. If I graph this first one in red, my y-intercept is negative 2, and my slope is negative 1. So I'm going down 1 over 1, down 1 over 1. So my line is going to look something like this. And it would keep going up this way. I'm going to cover the whole coordinate plane. Okay? And then if I put in my test point, 0 greater than 0 minus 2, is 0 greater than negative 2? Yes, it is. So I would shade in this direction. Now let's try our second line. So I'll graph this one in blue. So my y-intercept is 6. My slope is 3. So I could either go up 3 and to the right 1, or I could go down 3 and to the left 1, and down 3 and to the left 1, and down 3 and to the left 1. And my line would look, sorry about that, like this. And then if I put my test point in, is 0 less than or equal to 0 plus 6? Well, yes, 0 is less than or equal to 6, so 0, 0 is a solution. So I would be shading in this region. So then the solution to the system of inequalities is the region where they are both shaded. So from here and everything over here would be the solution. Any ordered pair in this region is a solution because both the inequalities are shaded there. Let's try another one. So if this one is just taken one step further, I have 3 inequalities, but I'll graph this first one. Y is greater than or equal to negative 1. Going back one, guys, I forgot to make it a dashed line. So those lines both should have been dashed. I apologize for that mistake. So y is greater than or equal to negative 1. I go to where y is -1 and draw in my horizontal line. That one gets to be solid, so I don't have to mess this one up. Then I'm going to use another color for the next one. Let's do red. For this one, x is greater than -2. This will be a dashed line, vertical line. Oh, I forgot to go through and shade the first one. So let's shade this first one. Is 0 greater than or equal to -1? Yes, it is. So I would shade above here. All the points above. And then for the second one, x is greater than -2. Well, that would be shaded this way. So right now my shaded region is in this area, right? But let's see if we can find some more. So graphing this last one, I first need to solve for y. So I would say 2y is less than or equal to 4 minus x divided by 2y is less than or equal to 2 minus 1/2 x. So my y-intercept is 2, down 1 over 2, down 1 over 2, and my line is solid, and it would look like this. Keep going up. And then if I put 0 in, is 0 less than or equal to 2? It is, so I would want to shade towards 0, 0. So now looking, the region, it's kind of hard to see this completely, but the region that they're both shaded, we're shaded to the right of this line, so it would be over here, above this blue line, and below the purple line. So this triangle here makes up all the possible solutions. Okay? It is helpful to use other colors in this, and I'm actually not going to use blue anymore because that blue of the axes can be a little confusing. Let's look at another one, because the more... So now this one's a little bit trickier. It's asking me to write the system of linear inequalities. So if I look at this, I have this line here. And this line, I know it's a y because it's a horizontal line. And it's y and equals 3, or it's actually going to be, if I shade above, numbers up here, like 5 is greater than or equal to 3. So I would write that line. And then for this one, to write this line, my y-intercept is 1. So if I'm writing it as y equals, I'm not going to put the equal sign because I need to put an inequality sign. My slope is, if I'm going from here to here, up 2 over 1. So my slope is 2x plus 1. And then I shaded above this line, because if I put my pencil on it and move up, I'm in my shaded region. So that means that it's greater than. Because it's dashed, it would just be greater than. If I put my pencil on it and to get in the shaded, I would move down, then it would be a less than. So greater than is up. So is greater than or equal to are up. Less than and less than or equal to are down. Let's see if we can try another one of those because they can be tricky. Let's try one more together. This line here we can start with. It's an x and 3, and then if I look, I'm going to the left, which we said for x equals, it would be less than or equal to. And then for this line here, my y-intercept is -1, and my slope is up 1, 2 over 3. So I have a slope of 2/3. So my second equation would be y, from this line I'm going up, so is greater than 2/3 minus 1. So that would be my system of inequalities. Let's look at one quick word problem together. NCAA regulates lengths of aluminum baseball bats used by college baseball teams. The NCAA states that the length in inches of the bat minus the weight in ounces of the bat cannot exceed 3 pounds. So let's start with that to write it. The length, which let's set our length equal to x, minus the weight, we're going to set that equal to y, cannot exceed 3. So x minus y cannot exceed, so it's got to be less than or equal to 3. And bats can be purchased at lengths from 26 to 34. So x is either greater than or equal to 26, or x is less than or equal to 34 for it to be within this range. That would be our system of linear inequalities. So if we come here and we graph this, and we're going to count each of these blocks by 5. Oh, sorry, that would be 10. So each one is 5 there. Each one of these is 5. So first, let's do the 26 and 34. 5, 10, 15, 20. 25 is here. So the 26th line would come right around here. And then the 34 line would come right around, that was 26. 34 would be right around there. Just get as best as I can, right? I also know that both x and y have to be greater than 0. And I know that I already have x is greater than 26, so that's obvious. But y also has to be greater than 0. Because I can't buy a bat with a weight less than 0. That would just be, things can't have negative weights. So the last equation, this one I don't really have to graph because I just know that if it's got to be above this x-axis. It's got to be above that. Okay? And so then this last line that I have to graph is this one here. And when I solve for y, I'm going to get y is greater than or equal to negative 3 plus x. So my y-intercept is negative 3, which would be somewhere right around there. And then I go up 1 over 1, up 1 over 1, up 1 over 1. It's coming up right through these. And I can draw my line through. And let's see where I want to shade. So for this line here, this orange one that I'm doing right now, if I put the point 0, 0 in, is 0 greater than or equal to negative 3? Yes. So I would want to shade above this line. So in that region. And then for the red line, it would go that way. And the yellow line, it looks like, is going this way. So the region is kind of hard to see, but the region where they're both shaded, or all shaded, would be right in here. So that is where your solutions of the system are in that region. So then it asks me, if I have a bat that is 31 inches long and 25 ounces, will I be allowed to use it? So 25 ounces would come right at this line here. Right? Nope, up greater. Okay. So 25 ounces, 5, 10, 15, 20, 25 would be that line. And 31, 5, 10, 15, 20. The point would be right there. And we can tell that that is not in our pink region, so therefore, no, you cannot use that bat in the NCAA baseball games. All right? So that is it for today. If we look back at our anticipatory set where we were starting today, now can we think of a way that we could solve that? Well, yes, we could say that if we label the one score the musical valuation X and the visual Y, X cannot exceed, so it's got to be less than or equal to 60, and Y has to be less than or equal to 40. And so if we graph those on our number line, we have 60 over here, 40 up here, and we would find that our values would have to stay in between them, in that box there. Alright, so that's it for today, guys. I hope you have a good night. I'll see you tomorrow.